Good morning, everyone. In today's session, let's talk about exponential random variable. A continuous random variable x with probability density function f of x, which is equal to lambda e raised to minus lambda x when x greater than or equal to 0 and 0 otherwise, the lambda greater than 0 is called an exponential random variable. It's called an exponential random variable. We also say that x follows an exponential distribution with parameter lambda and write x to be x of lambda. Now, if we have a distribution function, the distribution cumulative distribution function for x greater than 0 is obtained as follows. The cumulative distribution function, which is denoted by capital F of x, which is giving the probability of x less than or equal to x, is given by integral minus infinity to x f of t dt, where f is the probability density function and f is lambda e raised to minus lambda t, and it is varying from 0 to x. Integral 0 to x lambda e raised to minus lambda t dt, which will be equal to 1 minus e raised to minus lambda x when x greater than 0. So if we take the probability that x greater than x, which is equal to 1 minus probability of x less than or equal to x, which is equal to 1 minus lambda e raised to minus lambda x, which is e raised to minus lambda x, because we already got probability of x less than or equal to x, which was f of x is equal to 1 minus e raised to minus lambda x. So I'm just writing, if x is an exponential random variable, then we can say that probability of x greater than or equal to greater than x is equal to e raised to minus lambda x, e raised to minus lambda x. Now let's move to expectation and variance of an exponential random variable. If x is an exponential random variable with parameter lambda, that is, you have the probability density function f of x is equal to lambda e raised to minus lambda x when x greater than or equal to 0, 0 otherwise. So if you have x to be an exponential random variable with parameter lambda, then the expectation of x or mean of x, the random variable, is given by 1 by lambda, and the variance of x is given by 1 by lambda square. That means that mean and standard deviation of an exponential random variable is equal to 1 by lambda, where lambda is the parameter corresponding to the exponential random variable. So let's see how to get this expectation of x is equal to 1 by lambda. Now we know that expectation of x is equal to integral minus infinity to infinity x times f of x dx, where f is the probability density function. So minus infinity to infinity. So here the function is defined for x greater than or equal to 0. So I'm rewriting the limit as 0 to infinity x times lambda e raised to minus lambda x dx. So after doing this integral, you will be getting expectation equal to 1 by lambda. Similarly, we know that variance of x is given by expectation of x square minus expectation of x the whole square, where expectation of x square is obtained using minus infinity to infinity x square f of x dx, and in this case the limit is from 0 to infinity because everywhere else it is equal to 0, x square lambda e raised to minus lambda x dx. So after doing this computations, you will get variance of x is equal to 1 by lambda square. Now we have an important property for the exponential random variable. If you have exponential random variable x with parameter lambda, then the probability of x greater than x plus a, given x is greater than a, is same as probability of x greater than x, where a and x are greater than or equal to 0. So probability of a given b, we know that probability of A given B is equal to probability of A intersection B divided by probability of B. Similarly, in this case, probability of x greater than x plus A intersection with x greater than A divided by probability of x greater than A is equal to probability of x greater than x plus A by probability of x greater than A, because the intersection is the set x greater than x plus A. Now we already saw that probability of x greater than x is given by e raised to minus lambda x. So using that, probability of x greater than x plus a is given by e raised to minus lambda x plus a divided by probability of x greater than a is e raised to minus lambda a. Hence, cancelling e raised to minus lambda a, we will get e raised to minus lambda x, which is equal to probability of x greater than probability of x greater than or equal to greater than x. So probability of x given x plus a, provided x probability of x greater than x plus a given x greater than a is same as probability of x greater than a. This is an important property of the exponential random variable. Now let's do a problem. If the distance that a car can run before its battery wears out is exponentially distributed with an average value of 5,000 kilometer, if the owner decides to take a 2,000 kilometers trip, what is the probability that he will be able to complete his trip without having to replace the car battery? So we have expectation of x given to be equal to 5,000, and we know the expectation of an exponential random variable here x, which is the distance covered by the car, is exponentially distributed. X is approximately exponential of lambda. Now to obtain the value of lambda, we are given expectation. So 1 by lambda is equal to 5,000. Hence lambda is equal to 1 by 5,000. Now we are asked to find the probability that x greater than 2,000 is given by e raised to minus lambda into 2000, using the property that probability of x greater than x is given by e raised to minus lambda x. So we are using this property to find the probability of x greater than 2000, and we got e raised to minus lambda is 1 by 5000 into 2000, that is equal to e raised to minus 2 by 5. So this will be the probability that the owner can complete the trip without having to replace the car battery. Now let's move to a second problem. In a city, the daily consumption of milk in excess of 20,000 gallons is approximately exponentially distributed with mean 30,000 gallons. The city has a daily stock of 35,000 gallons. What is the probability that out of 2 days selected at random, the stock is insufficient for both the days? So we have X to be the daily consumption, excess daily consumption, and we know that X is approximately X is having an exponential distribution, exponential of lambda, where 1 by expectation of X is given to be equal to 1 by lambda, which is 3000. We will get lambda to be equal to 1 by 3000. 1 by 3000. Now let y denote, let y, the variable y is denoting the total daily consumption. X was the daily consumption of excess milk and y is giving you the total daily consumption, which is 20,000 plus the variable X. Now we are asked what is the probability that out of 2 days selected at random the stock is insufficient for both the days. That means probability that X greater than Y, probability of Y, which is the total consumption, is greater than 35,000, because our stock, daily stock is 35,000 and we will be out of stock if Y is greater than 35,000. That means probability of 20,000 plus X, 20,000 plus X is greater than 20,000 plus X is greater than 35,000. This is equal to probability of X greater than 15,000. Probability of X greater than 15,000. Now how to find probability of X greater than 15,000, which is equal to probability e raised to minus lambda, we got it as 1 by 3,000, 1 by 3,000 into X is 15,000. So e raised to minus 5. The probability that y greater than 35,000 or we are having insufficient stock is given by e raised to minus 5. Now we are considering out of 2 days selected at random, the stock is insufficient for both days is given by, so for 1 day we are having the probability e raised to minus 5, and for both days the probability that the stock is insufficient will be given by e raised to minus 5 into e raised to minus 5, which is equal to e raised to minus 10. And that's all. Thank you.